Okay, folks, today's lesson is called the cosine law. Um, and again, similar to the sine law, this is used in non-right triangles, okay? So maybe we can write that in. This is for non-right triangles, and we'll put that somewhere at the top, or maybe not. Um, first, let's go over so far what we know. Now, if we have a right triangle, we can use the Pythagorean theorem, and we can use SOHCAHTOA. Now, those are the only way. That's the only way that we can use either of those is if we're given a right triangle. Now, in a non-right triangle, if we know a side length and its opposite angle, we can use the sine law. So what I mean by that is if we're given a nasty triangle, right, a non-right angle triangle, ABC, and we have little a, we have over here little b, we have over here little c. These are the side lengths. Initially, what we do is we see the triangle, we notice that it's a non-right angle. And then what we go hunting for is an angle and its opposite side length. If those are given to us, then we know that we have a usable ratio. And having a usable ratio allows us to solve for either another side or another angle. And that's dependent on other information that you're given. So let's just say in this example, we are given angle B, or we're given side length B, but we're not given angle B. What we do is use that usable ratio with the B ratio here, the sine B over B, and that's it. And we take off, and that was the sine law, and we got really good at it. Now, today's lesson focuses on the what if. What if that didn't work? And I'll show you what I mean by it not working. Here we have two triangles. It says here, write out the sine law for each diagram. And just for the sake, it doesn't really specify anything about what we're solving for. I'm just going to write the sine law with the angles on top. So we have here angle A, and that means this is side length A. We have huge angle B, and that's how we get, huge side length B. And then angle C and side length C. So when I set up the sine law, and I said I'm just going to put the angles on top for honestly no reason, I'm going to fill everything in here. So I could only fill in the side lengths. Notice that right here at the bottom, I could fill in 45 for side A, 62 for side B, and 40 for side C. And none of these ratios are usable. None of them. So it's like, uh-oh, that's not going to work now, is it? Okay. Maybe that's a fluke. I don't know. Let's try this one. We have angle F, right? Little f is over here. We don't know what it is. Angle T we don't have. Little t over here. Angle M and side length M. Okay? So we're going to set up our sine law with the angles on top. Why not? And when we fill this in, it looks something like this. We fill in 80 degrees for angle F, and that's it for that ratio. And we only have the side lengths for the next two ratios. So if you look closely, this is all we're able to fill in, which leaves us again in a situation where there's no usable ratio. And it says here in a big red box, it says you must have one complete ratio and one other ratio with only one unknown to be able to move forward with the sine law. Now, these are two extremely specific situations where the sine law does not work because there's no matching ratios here. There's no like we don't have like an angle and a side length A, an angle A and a side A. So none of these will be complete. Now, this triangle over here is very specific. It's called a side triangle. So it's called side because that we're given all three of the sides. And this is a situation where the sine law will not work. In this example, we have two side lengths, right? And an angle contained between them, okay? So what we call this is side angle side. And we have to write it like SAS, A in the middle, and the reason is because we're again reminding ourselves that the angle is contained between the two side lengths, and it's got to be specifically like this for the sine law not to work. And this is where, folks, this is where the cosine law comes into play. Now, there's a lot of information here on this slide. Now, we're going to go through it kind of slow for a good reason. Now, you can use the cosine law to solve for sides, and you can also use the cosine law to solve for angles. Really, I remember when I learned the cosine law way back in the day, we're only given this, and we used this cosine law right here to solve for both angles and sides. But nowadays, we like to give you this version of the cosine law, which is really the same thing as the original one up here. It's just rearranged a little bit nicer so that you can just plug in and solve for the angle, okay? And again, we're solving for angles, so we're not surprised to see that cos inverse. So what I'm going to focus on right now is perhaps just the top part of this right here, okay? So, folks, whenever we're solving for a side, okay, so just the side, we're going to be using, well, one of the three. Now, because all these cosine laws are literally the same thing. They're just a little bit rearranged. Like you'll notice that the variables move around a little bit based on what you're solving for. So in this first example, like let's just say we're solving for A. We're solving for A, okay? And this will only work if you're given a situation of side, angle, side, right? So let's just say we're given side, angle, and side. Let's just say we're given that. This will allow us to solve for for side length A, given this little situation. Very similar, if we go back a slide, it's very similar to this one right here. And I have that diagram right here as well. So in this particular one, we are given the two sides and the angle, and therefore we are allowed to solve for this side here using the cosine law. But notice it gets a little bit weird, and I say a little bit weird because it's all jumbled up. But what I want to do is go and look into the commonalities between the three of these. Okay, the three of these. Why are they similar? Why do I say that they're the same thing? Well, folks, if we're solving for side length A, that means that we are given side length B and side length C, and then you'll see them appear here again, right? Because we're given B, we're given C. And lastly, we're also given that angle A right here, so that we'll take the cos of angle A. Now let's see how that plays out in the next one. So in this case, we're solving for B, okay? Well, if we're solving for side length B, that means we must have angle B, and it also must mean we have A and C. And again, if we're solving for C, we're definitely given angle C, and we're also given A and B. So you're always gonna have one of these on a test or exam or something like that. But the trick is that we got to get a little bit better at rearranging this to make it kind of do what we want. So when we're given a side angle side, we're solving for that third side by using this version of the cosine law. Now let's have a look down here. Side, side, side. Of course, that means we're solving for at least one of the angles, right? Because we're already given all three of the side lengths. Let's have a look at this. It's angle A, and we know it's angle A because it's a capital A. Whenever we're solving for angle A, it means that we're also given all three sides. So that means we're given A, B, and C. Notice that this A squared, side length A, will go first. So it's A squared minus B squared minus C squared minus 2B times C. Again, you won't have to memorize this by any means. You'll have this, but the trick will be to rearrange it on your own to get these. And it's not so bad once you understand the pattern that's happening here. We're solving for angle B. We got side length B squared to begin, and it's always minus A squared minus C squared divided by negative 2AC. See how it's AC over here, then AC down here, right? You see the little pattern that's happening there? Same thing for C. C will start minus A squared B squared divided by negative 2AB. Now, you might have to spend some time just on this particular slide and have a look a little bit closer at each formula. So again, this is the same formula for all 6 of these. The bottom one's rearranged a little bit nicer, and then the rest of them are kind of just rearranged a little bit. So have a look at this, and we got to get good at really understanding, and not necessarily memorizing, but understanding the patterns that are going on in both of these cosine formulas. So the reason why is because what if we're given a random triangle like QRS? Notice how it's no longer ABC. It's like, uh-oh. So it says here, for triangle QRS, set up the cosine law for S. So we're solving for side length S. So we're going to start off with S squared. S squared equals, because we're solving for S, all right. So this is triangle QRS. If we're solving for side length S, that must mean that we are given the other 2 side lengths and also angle S. So the other 2 side lengths would be Q and R. So we can say Q squared plus R squared, okay, minus 2QR minus 2QR times the cos of, if we go back here, the cos of, well, it's the cos of angle S. Like that. Okay. And now over here, they want us to solve for angle R. So R will equal the cos inverse of, now because it's angle R, we're going to start off with R squared, right, minus Q squared minus S squared. So far so good. Divided by negative 2 QS. Close the bracket. Like that. So let me just have it written a little bit nicer for us here. Hey. Aha. Like that. Wonderful. Let's do an example of where this comes into play. So it says solve the triangle ABC. Solve the entire triangle. Okay. So if we look closely at this one, my first plan of attack is I notice that this is a non-right angled triangle. So SOHCAHTOA goes right out the window. Pythagorean theorem right behind it. So my first in line is looking for the sine law, because I'm very familiar with the sine law already. And I got no angle A but side A, no angle B but side B, and then no side C, but I have, you see, so there's no matching angle and corresponding side length, so therefore the sine law will not work. If I have a closer look at this, I see side, angle, side. This is an SAS triangle. Maybe I can write that up here somewhere. SAS. And if I have an SAS, believe it or not, that's an S. If I have an SAS triangle, that means that I'm going to be solving for the side length that is opposite to that angle. So we're going to be solving for side length C first. So let's get going with that. Solve for side C. So for solving for side C, we're going to use the side length cosine law, solving for C. So maybe right now you can pause the video and try to write it out on your own. You could say c squared equals, and then try to practice that. But it's going to be c squared equals a squared plus b squared minus 2ab multiplied by the cos of angle C. Okay, once we have that, we got to be a little bit cautious here. In our next line, we're going to fill in the blanks. Okay, because I know that this is little a, and I know that this is little b, right? So every time I see an a in the formula, I'm going to plug in 17. Every time I see a b in the formula, I'm going to plug in 28. And I notice 52 degrees will go in for capital C. Now, when I do this, I'm going to take this chunk by chunk, okay? What I mean by that is, first I'm going to do 17 squared, okay, get 289. Plus, then I'm going to do 28 squared and get 784, okay? Minus, and then I do 2 times all of this in my calculator. So I can put this directly into my calculator with a minus sign here, and I get minus 586, and then I got 0.10972, and it goes on and on and on and on. But because it was 0.10, I'm just going to leave it as 586, just for the sake of the numbers looking a little bit less scary. In my next line, I'm going to condense this, collect our like terms here, right in the calculator again, all in one shot. And because we have c squared over here, the opposite of squaring is square rooting. So we square root this nasty number, and we get something like 22.1 for side length C. 22.1. Great. So we have C. C is now solved for. That is awesome. Next, we're going to do either B or A. We're going to solve for either B. So I chose to solve for B. Now, let's pause right here for a moment. At this point in solving triangles, if you were the type of person you just loved the sine law, you are totally able to use the sine law here, because once we solved for side length C, now we have an angle and its opposite side length. We have that usable ratio in the sine law. But folks, just for the sake of teaching the cosine law, I'm going to solve for angle B just by using the cosine law. It will work using the sine law, okay? But just for the sake of this lesson, I'm just going to use the cosine law. So we're going to say angle B equals, and again, if you want to pause at this point and try to figure out what those next values will be just by looking ahead, by all means. So B equals the cosine inverse of, yes, B squared minus A squared minus C squared divided by -2 times A times C. Now we're going to fill in all of the blanks as best we can, and it gets a little crazy, and that's okay. We just plugged in the values, right? For B would be 28, 17 would be for A, and now our newly solved 22.1, right? That really helped us out here. Divided by -2 times 17 times 22.1. Now, whenever we're solving any sort of thing in a fraction, my best advice would be to first simplify the top, then simplify the bottom, and then lastly, you can divide. So we're going to go ahead and do that. We simplify the top. I just plugged it right into my calculator all in one shot, and I got 6.59. I simplify the bottom in my calculator all in one shot. And again, be very careful with your negatives. Extremely careful. Even careful with your negatives over here as well. Okay. Next, I'm going to divide these two, get a decimal, and I try to round it to 4. Hey, that should be negative. I try to round it to 4 decimal places. So my decimal is something like 0.00877. So I put 0.0088. I do the cos inverse of that negative decimal, and we get something like 90 second function cos of that. 90.50 degrees. So look at that. It was almost a right triangle, but not quite a right triangle. And if you were to use the sine law here, you'd get the very, very... I honestly want to say a similar answer because all this rounding that we have going on, it might be a little bit different than 90.5, but it'll be definitely in the ballpark. Okay. So now over here we can go and plug in 90.5. Now we have one more thing to solve for, and that would be, that would be angle A. And let's not break our backs here using either the sine law or the cosine law. We have 2 out of the 3 angles, so let's make life a little bit easier. Angle A is equal to 180 minus C minus B, right? We plug everything in right into our calculator, and Bob is your uncle, right there, 37.5 degrees. So we've solved the entire triangle. Folks, a little bit of homework here. Page 443, numbers 1, 2, 3, and 4. Again, I really want to highlight a couple things before I end this. First, this right here, this method of solving this in chunks is extremely important. Next, I also want to remind you, I know it's minus all of this, minus 2 times all of this. However, sometimes all of this will give you a negative outcome. So it's going to be like minus negative 400, for example, which really means plus 400. So be extremely careful. So if you do get a wrong answer, don't lose your mind. Just look right here at this sign and go through everything with a fine-tooth comb and be very meticulous with this type of stuff. But anyways, if you do have any questions or if you run into any errors or problems, please feel free to let me know. Send me an email. I'm always here to help. All right, have fun.